Hello guys, so in this video we are going to look at equations reducible to exact form, and we have already discussed rule 1, 2 and 3, and today we are going to discuss the last rule, rule number 4. So actually I am following the book by H.K. Das, and in that there is actually another rule in between rule number 3 and 4, but I am skipping that rule because that rule is kind of very peculiar and specific. That rule applies to very peculiar and specific differential equations, which I personally haven't seen by far in all of the physics. Like, they might be useful, but they are very rare. So anyways, so we are going to skip over that and we are going to go over rule number 4 straight away. So let's see what is rule number 4. So in rule number 4, let's see on what type of differential equations does it apply. So if we have our usual form, m of xy dx plus n of xy dy equal to 0, then this equation can be reduced to exact form using rule number 4 if the condition is that m and n both are homogeneous. This also has to be homogeneous. Both are homogeneous functions and both are of same degree. Now what does all this mean? Let's take a look by just a dummy example. Let's say m is some function xy plus x square and n is some function, let's say x square plus y square, right? So here we can see that this m is actually homogeneous means that in each term the total power of x and y should be same. So here total power is squared, x square. Here also 1x and 1y is there, so total power is 2. So this has degree 2, right? And similarly here also we can from here we can directly see that both have degree of 2. So this also has a degree of 2. So both of these are homogeneous differential equations, and now the condition is that both should have same degree as well, right? And here we can see that they do have same degree. If this was, let's say, x cube, these both were x cube, then this would have the degree, its degree would be 3, and then this won't be an exact then the degrees of m and n won't match, right? But for to apply rule number 4, the degrees should match, and then only we can apply this rule. And now once we have recognized this thing that they both m and n are homogeneous, then straight up we have our integrating factor, which is 1 divided by mx plus ny. Now you can see that this integrating factor is quite easy to remember, especially because the integrating factor in rule number 3, if you remember, let's write it down here. If you remember, in rule number 3 we had rule number 3's integrating factor was almost same. It was mx minus ny. So this minus sign changes here, that's the only difference, right? Otherwise it is exactly the same as rule number 3. So now let's take a look at a simple example to see how this rule works. So here we have an example. This is our differential equation, dy by dx is equal to this thing. Now one interesting thing, so before anything, first of all let's write this down in the form which we are used to. If we cross multiply these terms, we will get dy times xy square is equal to dx times x cube plus y cube, right? And now we can take dy there, so we will have 0 is equal to dx times x cube plus y cube minus dy is multiplied by xy square, right? So here we can see that this is our m and this is our n, with the minus sign is included in n actually. Now here yeah, actually this is x cube, yeah, this is x cube. Now here we can see that the degree of this is 3, right? The degree is 3, and also this is homogeneous, right? Like all the terms have same degree of 3. Here also the total degree is 3 because there are 2 for y and 1 for x, right? So total degree here is also 3. So both have both have the degree of 3, right? So now we can apply rule number 4 and use the integrating factor. Before doing that, one interesting thing you might notice here is that whenever rule number 4 is applicable, you will notice that we will be able to write our differential equation in this form, right? And here you can see that this is actually a homogeneous differential equation, which we already discussed about, right? And we saw how to solve this by writing it in form of y by x and then doing that v substitution, right? And yeah, you can actually solve this equation by this method, and it is quite a simple equation, and solving it by homogeneous method will be a good idea as well. But still, so uh, all the equation which we will solve using rule number 4 are all homogeneous differential equation which can be solved by that method as well. Anyways, let's continue with our current solution. Yeah, so let's first of all find the integrating factor. Integrating factor will be 1 divided by m times x. So this will become x to the power 4 plus xy cube, right? Then plus y times n. So y times n will become, there is a minus sign here, so xy cube. So these things will cancel out, and integrating factor is simply 1 by x to the power 4. Now we just need to multiply this to our original equation. So let's take our original equation and multiply this thing by 1 by x to the power 4. So if we multiply x to the power 4 here and also here, then we will get 1 divided by x plus y cube divided by x to the power 4 dx minus y square by x cube dy. Now this is an exact differential equation, so we just need to put those integration signs, integration here, integration here. Now let's just integrate this. So we will get a constant here, and integral of 1 by x will be ln of x plus this will become y cube, and x raised to minus 4, this will become x raised to minus 3, and we will get a minus 3 here. So I will put a minus sign here for now, and in this equation actually there is an x term, so we don't need to integrate this. So there nothing more need to be done. This is the solution, so we can write it a little bit neatly, I guess. So ln of x minus y cube divided by 3x. This is the solution of our differential equation. So we have completed all the rules. All the rules are now complete for converting non-exact differential equation into exact differential equation. In the next video we will take a look at some different kind of differential equations. Now the exact differential equation part is over, and I hope that you have understood exact differential equations nicely, and I will see you in the next video.